Thank you, Tuna and Dennis, for some very interesting and insightful presentations. We have time for a couple of questions. Unfortunately, Dennis cannot join us live due to the time zones, but we do have Tuna here. So, Tuna, just a quick question here. You mentioned in your presentation about whether we should be using more than a single performance expectation in building codes. And also that the different exceedance levels for different performance metrics. So do you have any thoughts about what other performance standards might be included in future iterations of the code?
Thank you, Jill. Yeah, I really see a shift from trying to prevent collapse at a single level of shaking to make our communities a bit more resilient, to also consider things like making damage more repairable, easier to keep people in their homes and buildings after an earthquake. Of course, life safety is always going to be, I think, building codes first and foremost priority. That alone, that kind of probability levels that we need to think about perhaps more carefully as to what kind of risk do we expect in terms of the collapse of our buildings. But I think more and more we're realizing earthquakes cause so much damage after an earthquake that even if the buildings haven't collapsed, a good portion of the buildings have to be torn down and rebuilt. And is that an acceptable performance? So both of those, I think, are important considerations that go into each country's risk conversations. Now, when we talk about 2% chance of exceedance in 50 years, what we're basically saying is are we okay with that kind of probability that our buildings, what we normally aim for, non-collapse, but what if at 2% chance they collapse and kill people? Is that an acceptable risk?
Yes, thank you, Tuna. That's a very useful commentary about what is acceptable risk or tolerable risk. And maybe we'll touch on that later as well in the conversations. Another question for you. I found the illustration of how building codes have evolved over the last 100 years as really insightful, and to see how things have changed, particularly over the last kind of 20 or 30 years. So if you could look in your crystal ball, how do you think things might evolve in the next kind of 10 or 20 years, particularly where I guess the earth science is evolving to the extent where you can have a much better handle on the uncertainty associated with a hazard rather than kind of single or just a single curve, say, for example, into the building code?
Yeah, that's a very good question. So I think over time, you've seen how complex it's already become. And one of the challenges, I think, to go with that is the complexity of the hazard being reflected into the building code. But I think as important is the downstream from that, as we make the code more complicated, because it's not just the hazard part, it's also the engineering part becomes more complicated. We have many more pages of code material now than we had 40, 50 years ago. But that means that the enforcement, the compliance with the code has become more complicated too. So the municipal officials have to educate themselves on the code and understand those requirements to be able to effectively assure compliance with the code. In terms of the hazard, you're absolutely right. Seismic hazard, particularly because damaging earthquakes happen so rarely, and we have only 100 years of recorded seismicity history, we're dealing with a lot of uncertainty in hazard estimates. Now, it's been challenging to put all of that into a building code context, mainly because in engineering and the building code, we have to make fairly certain or deterministic requirements for the engineers to follow. However, I do believe that we have room for accounting for uncertainties in the hazard a little bit better. in future codes. And I think perhaps this kind of performance goals would help with that. I think that conversation, it would basically making the code, instead of a single predetermined level, we're making almost bringing it to a more probabilistically aligned approach. And I think there might be room in there to account for uncertainties a little bit better, define different performance goals with that uncertainty in mind.
Yes, thank you. Thank you, Tuna. A couple of questions here around kind of capacity and capability development. I know that you've worked across many different countries, training and building capacity. So do you have any observations or recommendations about capacity development for, as you just touched on, municipal officials, or for other stakeholders that might need to be interpreting and using the seismic code, and whether that could be appropriately done on a regional basis?
Yeah. So in many parts of the world, what is you're absolutely right. I think the capacity lacking is a big problem, because for the code to be effective, there are really three components to it. One is the code development itself, and that by itself requires a lot of capacity building in science and engineering. There is engineering education to follow the code, understand the code, and follow the code, and issues related to that. So if the engineers aren't able to keep up with the code updates and the new developments in the code, then this process is going to break down. But also, in many of these places, the education of the construction, the actual what is being constructed on the ground, so the education of the construction crew and the knowledge transfer between the engineering design and the actual construction process is also sometimes requires a little bit more education, more capacity building, and the municipality's ability to enforce the code. So it's in governance, it's in building code development, it's in engineering and science. So it's all of it has to be in place for the building code to be successful.
Yeah, that's a very good point. It's very much a system approach, isn't it? Rather than
System, yes, absolutely. Yeah. All of it has to be in place. Otherwise, with a fantastic code, but the code not being applied on the ground because the construction crews don't understand the significance of some portions of the design, and they change it slightly on the ground, that what seems slightly to them may actually be a key component of the seismic resistance of the building. And we can't have any of those break down for the whole process to work and for risk reduction, building codes being used as a risk reduction tool.
Well, thank you very much. I think that's we're coming towards the end of the Q&A session there. I noticed in the questions there was a question for Dennis as well, but unfortunately he can't be here live, so I think we can probably pass that on through the mechanisms of the WCOG's website later. So we're unable to answer that question right now. Okay, I think that was a really fascinating session and a really good introduction to the webinar series today.